Good day, guys. We are given a question on wave motion. In this question, we are given the equation of a wave motion, which is what y equals to 5 sine 3x minus 40, where y is in centimeters, x is in centimeters, t is in seconds, and we are to determine the amplitude, the frequency, the period, and the speed of the wave. So the solution: first and foremost, write the equation out again. So y is equals to 5 sine 3x minus 4t. So the original or the base equation for a wave motion is y is equals to a sine 2 pi x over lambda, 2 pi x over lambda minus omega t, where a is the amplitude, x is the displacement, lambda is the wavelength, omega is the angular speed, and t is the time, not the period. T is the time. So comparing the equations, we can conclude that the amplitude a, so amplitude a is equals to 5 centimeter. Because y is in centimeter, because the displacement x and y is in centimeter, so that's what the amplitude will take. A is equals to 5 centimeter. You can see a is here, 5 is here. So we have to find the frequency. Of the wave. So before we do that, we can find the angular speed of the wave. Remember that omega is equal to what? 2 pi f, and we have omega in this equation, so we can equate to this. From this, if you look at it, we have minus 40 and we have minus omega t, so we can conclude that omega is equals to what? 4. So 4 is equals to 2 pi f, then f is equals to 4 over 2 pi, giving us 2 over pi. F is equals to, let me get my calculator. So 2 divided by so that will be 2 divided by pi is 3.14, giving us 0.637 hertz. So I found the frequency f. Now we have to find the third one, which is the period. Remember that frequency f, small f o, is equals to 1 over the period, and period is in big T, and we have our frequency at 0.637. so that means what? T, our period, is equals to 1 over f. So our period is 1 over 0.637, which is equals to 1 divided by 0.637. that will give us 1.56. Okay, we can convert it to 570 seconds. Period is in seconds, so our period is t equals 1.57 seconds. The last thing is to find what? The speed of the wave, which is what? IV. Speed of the wave v is equals to lambda f, that's wavelength times frequency. Speed of the wave is equals to wavelength times frequency. So now we have to find the wavelength in this question for us to solve IV. So if you compare the equations over here, 2 pi x over lambda is equals to 3x. Let's write it. 2 pi x over lambda is equals to what? 3x. So x cancel x, then we are left with 3 is equals to 2 pi over lambda, then 3 lambda is equals to 2 pi. Lambda is equals to 2 pi over 3. So let's calculate that. 2 pi over lambda over 3, 2 times pi divided by 3 will give us, our lambda is 2.09 centimeters. It's centimeters because our displacement too is in centimeters. So if that is what we have, and we already have our frequency to be 0.637 hertz, look at it over here, So we can just apply it directly into the formula. You can apply it into the formula that v is equals to lambda f, which is equals to, what's our lambda? 2.09 times f is what? 0.637 hertz. So our v, which is the velocity of the wave, is equals to 2.09 times 0.637, giving us 1.33 centimeter per second. Why is it centimeter per second? Because we were calculating all our distances in centimeter. So you can go further to convert it to meters by just dividing by 100. So this is how we solve questions like this on wave motion. Don't forget to like and subscribe and share. Thank you.